it's Lindquist here. So today we're going to talk about what is the unit circle. This unit circle has a radius of 1 unit and is centered at the origin 0, 0. It's used to find exact coordinates for a rotation. Okay, there are 4 quadrants. We're going to label quadrants 1, 2, 3, and 4 and their signs. So quadrant 1, we know that the signs are both going to be positive for x and for y for any point on the circle. In quadrant 2, our signs are going to be negative, positive, because our x is negative and our y is positive. In quadrant 3, my signs are going to be negative, negative. Both x and y are negative. And in quadrant 4, the signs are going to be positive, negative. X is positive, y is negative. Positive rotations are counterclockwise from 1, 0. So here's 1, 0 right there. So a positive rotation is going to go that direction, counterclockwise. Likewise, negative rotations would be clockwise from 1, 0. So let's refresh our right triangle. So we have our 30, 60, 90, where we know that our short leg is a half. Our long leg is root 3 divided by 2, and our hypotenuse is 1. And then we have our 45, 45, 90, where our hypotenuse is 1, and both of our legs are square root of 2 divided by 2. All right, so let's take a moment to write out our multiples of 30 degrees. So this would be a 30-degree rotation, 60-degree rotation, 90-degree rotation, and so on around the circle. And then, of course, we're back to a 0-degree rotation, which is once around the circle, or 360 degrees. Let's do the same thing for our multiples of 45. So again, this is a 0-degree rotation, 45, and then go ahead around the circle. And back for a 360 rotation, which is once around the circle. Okay, so without using your big unit circle, find the exact coordinates for each rotation. Find the sine or cosine value indicated. So we know that a rotation of 135 degrees is one of our multiples of 45. So if you think about here, we start with 0, and this is 45 degrees, 90 degrees, and we end up at 135. So this is the rotation that we're referring to. So this point right here, this is my rotation of 135 degrees. So I'm going to draw my reference triangle in. So I'm always drawing a vertical line to my x-axis. And so we know that our reference angle here is a 45-degree angle. So we have a 45, 45, 90. And we know that our hypotenuse is 1. So in a 45, 45, 90, where our hypotenuse is 1, my y is going to be root 2 divided by 2. I'm going up that amount. And my x, since I'm going left, would be negative root 2 over 2. So if they ask you for the cosine is adjacent over hypotenuse. So adjacent would be the negative root 2 over 2 over 1. That would be just negative root 2 over 2. So you can think of your cosine as being your x, because it's always the adjacent side is going to be horizontal. And then my sine is opposite over hypotenuse. So my opposite is going to be the root 2 over 2 over 1. So again, it's going to be just root 2 over 2. And it's going to be my y value. So you can always think of cosine as being x and sine as being y. So let's take a look at this one. So cosine and sine of 210 degrees. We should recognize that 210 degrees is a multiple of 30, not 45. So we have 30, 60, 90, 120, 150, 180, and here we are at 210 degrees. So this is the location that we're referring to. So we're going to draw out our reference triangle. So this angle right here is 30 degrees, which makes our short leg negative 1/2, negative because we are going down to get to our coordinate. And our long leg is going to be negative √3/2, again, because we are going left to get to our coordinate. And our hypotenuse is always 1. So cosine, again, is your x. If we look at our x coordinate, it's the negative √3/2. That is our adjacent leg. So cosine is always x. And sine is always going to be the y coordinate. So it will be negative 1/2. Okay, so for number 3, they're asking you for the cosine of 90 degrees and the sine of 90 degrees. Well, 90 degrees is up here at this coordinate at the top. So this is the coordinate 0, 1. So our rotation just basically goes from here to here. So there is no triangle for this one. So then how do we find the cosine? Well, if you remember that cosine is the x coordinate of your rotation. So in this example, my cosine is going to be 0. Likewise, my sine is my y coordinate of my rotation. So my sine value for a rotation of 90 degrees is going to equal 1. So go ahead and try example 4. Pause the video and try it out. Did you put 270 degrees down here at this bottom point? Because remember, this is 0, 90, 180, 270. Okay, so my initial side is here and my terminal side is here. So this rotation counterclockwise is 270 degrees. And the coordinate for this location would be 0, negative 1. So what would be our cosine for this angle? Well, if you said 0, you'd be correct because, again, cosine is our x. And then sine should be negative 1 because that is the y coordinate of our rotation. All right, so for the last 2 examples, it says find the exact coordinates x, y for each rotation on the unit circle. So if we are doing a rotation of 330 degrees, we should recognize that as being a multiple of 30 degrees. So we can kind of just tick this out until we become comfortable. So we can tick this out, 30, 60. So here we are. The location, the coordinate we're looking for is this right here. So again, I'm going to draw a right triangle. I always do a vertical line up to my x-axis and then draw out the triangle. Okay, so here's my right triangle and here's my rotation of 330 degrees. So if this is 330 degrees, then this must be 30 degrees. So our length across from 30 is going to be negative 1/2, again, because we're going down. Our hypotenuse is 1, and our long leg across from 60 degrees is going to be √3 divided by 2. If we want to know what this coordinate is right here for a rotation of 330 degrees, the coordinate is going to be √3/2, comma, negative 1/2. So that would be your coordinate for this rotation. So if I asked you what the sine of 330 degrees is, hopefully you would tell me that the sine is negative 1/2 since it's the y coordinate of the rotation. And if I asked you what the cosine of 330 degrees is, that would be the √3/2, which would be the cosine. So, but again, they're asking you for the coordinate of this rotation, which would be √3/2, comma, negative 1/2. So that is what they are looking for in this particular problem. Okay, so just a reminder, this is your cosine of 330, and this is your sine of 330 degrees. So let's look at our last example. They're asking you to find the coordinates for a rotation of negative 135 degrees. So when you see this negative, it should clue you in that you are actually going to be going clockwise on this rotation. So if we start here at 0 degrees, then we're going to now, instead of going up 45, because again, this is a multiple of 45, this would be negative 45 degrees. We're going clockwise. This would be negative 90 degrees. And here is where we would have negative 135 degrees. So this would be the coordinates for the points we're looking for. So we're going to draw a triangle, so to the origin, and straight up perpendicular to the x-axis. Okay, so here's our right triangle. There's where our right angle would be. So this is a negative rotation of 135 degrees, which makes our reference angle 45. So again, our opposite side is going to be root 2 over 2, and that's going to be negative since we're going down to get to this point. And our x is also going to be negative since we're going left, so that would also be negative root 2 over 2. So the coordinate for this rotation is going to be negative root 2 over 2, comma, negative root 2 over 2. Again, this is my cosine, and the y-coordinate is my sine. Okay, to wrap it up, it says, based on what you found, what can we say about the x and y coordinates for any of these rotations? Well, we said that the x is our cosine, so cosine of our angle, and the y is the sine of our angle. Okay, well that's it for this lesson. If you have any questions, feel free to send them via Remind or on Schoology. All right, well that's a wrap. We'll see you next time.